So question number 1, use the Laplace transform, find the solutions for these following ODE. And this is our initial conditions. So what is the solution for this? Okay, so in this case, we have dy over dt is equal to 3 minus 2t. So we're going to use the Laplace transforms method to solve this ODE problem. So now we're going to put this into our Laplace operator. Okay, here we have dy over dt is equal to 3 Laplace operator of 1 minus 2, then Laplace operator t. So Laplace transform of the derivative, the first derivative will give us two terms, which is x, capital Yx, minus initial conditions y of 0. And this must be equal to Laplace transform of 1, give us 1 over x. And then Laplace transform of t, you cannot remember, let me make a remark for this. So Laplace transform of t of n is equal to n factorial as n plus 1. So Laplace transform of t is equal to 1 divided by x squared. So now we're going to substitute our initial conditions, okay, which is y of 0 is equal to 0. So here we have x, y of capital X is equal to 3 divided by x minus 2 over x squared. Okay, so now we're going to shift this x to the right hand side. We have this capital X. So here equal to 3 divided by x squared minus 2 divided by x cubed. Okay, so to find the solution, we take the inverse Laplace transform. Okay, so we take the inverse Laplace transforms, that we get yt. So yt is the inverse of this capital Yx. So now we can solve this individuals Laplace transform for each of these terms. So we have 1 over x squared minus 2. Then we take the inverse of 1 over s cubed. Okay. Now we see for the first term, the inverse of 1 over x squared is equal to t, right? So, so let me put a remark here. Okay. So now, so what is the inverse Laplace transform of this term? So remember, if we take the Laplace transform of t square, then you get 2 factorial x3, right? So now in this case is 1 over 3, so we need to multiply this by 1 over 2. So in this case, multiply by 1 over 2. Okay, so now we have minus 2. So this will be substituted with times 1 over 2 t squared. Okay, so in this case, we have 3 of t. So this can be cancelled, is minus t squared. So that is our solutions yt. Okay, so this is our solutions. Using the Laplace transform, find the solutions for the following ODE with these initial conditions. So let's see the solutions. So we have dy over dt is equal to exponential minus 3t. So using the Laplace transform methods, we're going to apply this Laplace operator on the derivative. So on both sides, exponential minus 3t. Okay, so the Laplace operations for the first derivative, we get 2 terms. Now here we have x, capital Y of x, minus initial condition y of 0. So the Laplace transform exponential minus 3t. This, let me give you the remark. If you take the Laplace transform of exponentials at, this is equal to 1 over x minus a. So in this case, what we can see here, a is equal to minus 3. So in this case, the Laplace transform of exponential minus 3t is equal to 1 over x minus minus, you get a positive 3. Okay, now we're going to substitute our initial conditions. What is the initial condition? Remember, the initial condition is y of 0 equal to 4. So here we have x, capital Yx, minus 4 equal to 1 over x plus 3. So we're going to shift this 4 to the right hand side. So this gives us 1 over x3 plus 4. And then we shift the x. Here we have 1 over x divided by x plus 3 plus 4 over x. Okay, so now we can separate this term into two parts. Okay, to do the Laplace, the inverse Laplace transform. So here we have 1 over x multiplied by x plus 3. This can be rewrite as a divided by x plus b x plus 3. So we need to find what is the value of a and b will equal the numerator. So the numerator is 1 on the left hand side, and the right hand side we have a times x plus 3 plus b of x. Okay, to find a and b, we can let x equal to minus 3. We substitute over these values, then 1 is equal to minus 3b. So from this, we can find what is the v value is minus 1 over 3. Okay, now let's assume that we're going to substitute x equal to 0. In this case, we have 1. So here we have 3a. Then we get the a value is 1 over 3. So we're going to substitute it back into these equations. And then we're going to take the inverse Laplace transform. So this capital Yx consists of a divided by x is 1 over 3 divided by 1 over x. Then minus 1 over 3 over x plus 3. So we have this 3 term here and plus 4 over x. Okay, now to find the solutions, we take the inverse Laplace transform. Okay, we take inverse Laplace transform. So yt is inverse of capital Yx. Okay, so we have 1 over 3. We take the inverse Laplace transform of this 1 over x. Then minus 1 over 3. Take the inverse of 1 over x plus 3. Here we take 4. And then so we're going to take the inverse Laplace transform of 1 over x. Okay, so in this case we have 1 over 3, because inverse Laplace transform 1 over x is equal to 1, right? So this is equal to 1. And then minus 1 over 3. So inverse of this, we get us the exponential term. EAT is minus 3t. Here we have 4. And inverse 1 over x is 1. So here we have yt is equal to 1 over 3 minus 1 over 3 exponential minus 3t plus 4. We can rewrite this. The solution is yt equal to 3. Okay, here we have 13 minus 1 over 3 exponential minus 3t. So that is our solution. Using the Laplace transform, find the solutions for this ODE with the initial conditions. So let's see the solutions. So we have dy over dt plus y equal to exponential t. Okay, so we can apply the Laplace operator on these equations. Okay. So Laplace operators apply on the first derivative, we get two terms. We have x, capital Y of x, minus initial conditions y of 0. Then Laplace transform of y is equal to capital Y of x. And here, Laplace transform of exponential t is equal to 1 over x minus 1. Okay. So we're going to substitute our initial conditions. Given this y of 0 is equal to 1, so we're going to substitute here. We have x, capital Yx minus 1 plus Yx is equal to 1 over x minus 1. So in this case, we can shift these ones to the right hand side. So we have x, y of x plus y of x equal to 1 over x minus 1 plus 1. Okay, now we can accumulate the yx factor. So we have x plus 1 is equal to 1 over x minus 1 plus 1. So we shift this x plus 1 to the right hand side. So here we have x plus 1, x minus 1. Here is 1 over x plus 1. Okay, so to find the inverse Laplace transform, we can separate this into two terms. Okay, so let's make a remark for here. Let me make a remark here. So we have the 1 over x plus 1, x minus 1. This is equal to a x plus 1 plus b x minus 1. Okay, we have to find a and b. So we're going to equal the numerator. So we have 1 on the left. This is a times x minus 1 plus b x plus 1. Okay, so we can let s equal to minus 1. S equal to minus 1, we can cancel the b and we find a. So here we have 1 is equal to minus minus is equal to minus 2a. Then you get the a value is equal to minus 1 over 2. Okay. Now we let s equal to 1. So we substitute into here. We have 1 on the left. 1 is 0. So you have 2b. So in this case, you have b equal to 1 over 2. Okay. So in this case, we have substitute back here y of x. So now we have this yx equal to a is minus 1 over 2 divided by x plus 1, then plus 1 over 2 x minus 1. Okay, and here we have this 1 over x plus 1. Okay. So now we can further simplify this because these two terms here, okay, can be calculated again in this case. So now we have 1 over 2, 1 over x minus 1. So we calculate this. Then you get positive 1 over 2, 1 over x plus 1. Okay. Now, to find the solutions, we're going to take the inverse Laplace transform. We apply the inverse Laplace operator to find yt for this capital Y of x. Okay. So now we have 1 over 2. Take the inverse Laplace transform of 1 over x minus 1. Then plus 1 over 2. Apply the inverse Laplace operator. Okay, so now in this case, we see here we have 1 over 2. So inverse Laplace operator of 1 over x minus 1 is give us the exponential term, okay, which is EAT exponential. So A in this case is positive 1, so we get exponential t. And then in this case, we have positive 1 over 2, so this one will give us negative t. Okay, so that is the solutions. Use the Laplace transform, find the solution for the following ODE with these initial conditions. So let's see the solutions for this. So we have dy dt minus 5y equal to 0. And then with the initial condition, y of 0 is equal to 2. So use the Laplace transform method. We're going to substitute this into our Laplace operator. So minus 5 Laplace of y equal to Laplace of 0. So this gives us two terms. We have x, capital Yx, minus initial condition y of 0, minus 5, capital Yx equal to 0. Okay, so in this case, we substitute our initial conditions. So minus 2, minus 5, capital Yx equal to 0. So in this case, we can factor out capital Yx. So here we have x minus 5. We can shift 2 to the right hand side. So now we have y of x is equal to 2 divided by x minus 5. Okay, to find the solution, we take the inverse Laplace transform. We get a yt. Yt is equal to inverse of capital y of x. So we have 2, take the inverse of 1 over x minus 5. So in this case, we have 2. So inverse of 1 over x minus give us an exponential term. EAT A is equal to 5. We get 5t. So our solution is yt equal to 2 times exponential 5t. Let's see the solution for this Laplace transform to find the solution of this ODE. So in this case, we have dy dt minus 5y equal to exponential 5 of t with the initial conditions y of 0 equal to 0. So using the Laplace transform method, we're going to substitute this into the Laplace operator. So we have Laplace of y equal to Laplace of exponential 5t. Okay, so here we have x, capital Yx, minus initial conditions, minus 5, capital Y of x. So Laplace transform of e exponential 5 of t is equal to 1 over x minus 5. Okay, so now we substitute the initial conditions. So y of 0 is equal to 0, 5, capital Yx, 1 over x minus 5. So in this case, we can factor out capital Yx. So here we have x minus 5 is equal to 1 over x minus 5. Okay, so we shift x minus 5 to the right hand side. So we have x minus 5 squared. Okay, to find the solution, we take the inverse Laplace transform. Okay, so yt is equal to the inverse of capital Yx. Okay, so in this case, we take the inverse of 1 over x minus 5 squared. Okay, so how to do this? Remember the first shifting theorem. Let me make a remark. If you take the Laplace transform of t of n small divided by the exponential at, then the result will be the n factorial x minus a. Here is n plus 1. So in this case, what we can see here, this is equivalent to n is equal to 1, so we have a t and exponential 5t. So that is our y of t. Okay. So let's see solution for these Laplace transforms. So we have dy dt minus 5y equal to exponential 5 of t, and our initial conditions y of 0 is equal to 2. Okay, so we're going to put the Laplace operator for the dy dt. Here is 5 Laplace operator of y, and then here we have exponential 5t. Okay, so this gives us two terms. We have x, capital yx, then minus the initial condition y of 0 minus 5 capital Y of x. So Laplace transform e 5t is equal to 1 over x minus a, so is x minus 5. So in this case, we substitute our initial conditions. So initial conditions y of 0 equal to 2, so 5 yx equal to 1 over x 5. Okay, now we can factor out y of x. We have x minus 5 here equal to 1 over x minus 5 plus 2. Okay, now we shift this x minus 5 to the right hand side. Then we have a capital yx is equal to 1 over x minus 5 square plus 2 over x minus 5. So to find the solutions, we're going to take inverse Laplace transform. So we get a yt, which is equal to inverse of capital Yx. Here we have inverse of the first term, x minus 5 square plus inverse. So we can shift out the constant 2. We take the inverse of 1 over x minus 5. Okay, so now we see for the first case, this is equal to t exponential 5t and plus 2. So 1 over x, you take the inverse, you get exponential at, which is 5 of t. So this is our solutions. Using the Laplace transform, find the solutions for this ODE with these two initial conditions. So this is the second ODE problem. So let's see the solutions. So we have this square y dt square equal to 3 plus 2t. Okay, so using the Laplace transform method, we're going to put this equation into our Laplace operator. This is equal to Laplace of 3 plus 2 Laplace transform of t. Okay, so in this case, second order derivative, when we do Laplace transform, we get 3 terms. So first term is s squared capital Yx, then minus x initial conditions y of 0 minus y prime of 0, and that must be equal to Laplace transform of 3 is equal to 3 1 over x plus Laplace transform of t. Let me make a remark for this Laplace transform. Okay, if you let the Laplace transform of t of n, this is equal to n factorial s n plus 1. So in this case, Laplace transform of t is equal to 1. So we have 1 x squared. Okay. Now we're going to substitute our initial conditions. So initial condition for this y of 0 is equal to a, and then y prime of 0 is equal to b. So we substitute here, we have x squared capital yx. So y of 0 is a, so we get ax. Y prime of 0 is b. So we have 3 over x plus 2 over x squared. Okay. So in this case, we can shift these two terms to the right hand side. So we have x squared, capital Yx, so equal to 3 over x plus 2 over x squared plus ax plus b. Okay. Now we can divide this whole equation by x squared so that we get yx on the left. Here we have 3 over x cubed plus 2 over x4 plus a over x plus v over x squared. Okay. So in that case, to find the solutions yt, we take the inverse Laplace transform of capital Yx. Okay, so we have 3, take the inverse Laplace transform of 1 over x cubed plus 2 inverse Laplace transform of 1 over x4 plus a inverse Laplace transform of 1 over x, then plus b inverse Laplace transform of 1 over x squared. Okay, so now we're going to solve for this. So inverse Laplace transform of 1 over x squared is what? So let me write the remark here. So remember, when we take the Laplace transform of t of n, this is equal to n factorial x n plus 1. So for the first terms, let's assume that we're going to take the Laplace transform of t squared. What do you get? You get 2 factorial is 2, x3. So you see in the first term over here, this term is 1 over x3. So here in this case, we're going to multiply this by 1 over 2. So in this case, also need to multiply by 1 over 2. So in that case, this is equivalent to t squared divided by 2. Okay? And then plus 2. So what is the inverse Laplace transform of this? So in that case, for this term here, 1 over x to the power of 4, this is equivalent to, if we take the Laplace transform of t to the power of 3, then we have 3 factorial. 3 times 2, we get 6. Here we have x4, right? So now, in this case, the numerator is 1, so here we need to divide by 6. So this also need to divide by 6. So now, in this case, this is replaced with t to the power of 3 divided by 6. Okay? Then inverse Laplace transform 1 over x is equal to 1. So it's a. And the b here for this term. So this one is equal to plus b t. Right? So now we can simplify this. So this is equal to 3 over 2 t squared plus t cubed divided by 3 plus b of t plus a. So this is our yt. Okay, so that is our solutions.